Hi guys, welcome to Leetcode November Challenge. Today we will discuss that how to convert a binary number which is stored in a linked list to its integer representation. So let's see what is the question. So question says that we are given a linked list and it consists of only ones and zeros, and this linked list is actually a binary representation of a number. So we have to find that what is that decimal value or the integer representation of that binary number which is represented by this linked list. So for example, we have a linked list consists of 101 and this is actually in base 2. So if you convert this into decimal, so this is actually 5. If you have only 1 in a linked list, then the decimal representation will be 1. If you have 0 in the linked list, then the decimal representation will be 0. And if you have this 10111, then the output will be 23. So here first we should recall that how to convert a binary number into a decimal number. For example, we are given this number 10111 in base 2. So we know that in binary each digit has some weight associated with it. So for example, with this bit the weight 1 is associated, with this 2, with this 4, then 8 and then 16. That means weight are like increasing and they are increasing in the multiples of 2. So how to convert this binary into the decimal representation? So what we do is we take each digit and then multiply with its weight. So weight is 1, so we write it as 2 to the power 0. Then we take this one and multiply it with 2. So we can write 2 to the power 1. Again we multiply this 1 into 4. 4 is 2 to the power 2 and so on. And after doing this, we add all these answers to combine the result and we get 23. For example, we have only 0, so we multiply this with its weight. So 0 into 2 to the power 0, that is 0 into 1, 0. So in our question, if this number is given, we should return 23 as the result. Before moving to the linked list case, let's see if this number is stored inside an array. Now, how to convert this binary representation into an integer representation? So in case of array, you know that you can move from left to right and right to left. Another thing is the indexes start from 0, 1 and so on. Next thing is when we are converting this number into its decimal value, we are actually multiplying each digit by some power of 2. So here we are multiplying it with 2 to the power 4, then power 3, then 2 and so on. So we know that we have to just take this element, multiply with some power of 2. Now the thing is how to generate this 4, 3, 2 and so on. So we can relate this 4, 3, 2 with this n. In this case, n equal to 5. That means we have to start this exponent or this power from 4. That is n minus 1. So what we can do is, let's say we are moving from the index 0 to n. That is we are moving from left to right. So we scan the whole array and we just multiply each digit, that is each ai, with some power of 2. Now we know this 2 and this 2 are same. Now 2 comma j. J means exponent. So how we are generating this j? J is starting with n minus 1. So in this case n equal to 5. That means j will start from 4. So here this means we are saying 1 multiply 1 is this, multiply 2 to the power j is 4. So this means 16. So this has been generated 16. Now we are storing this result inside this answer. Answer is initially 0. So answer will store my final output, or we can say decimal value. Now answer has 16. Now we have to decrement this power because we are moving from 4 to 3. So we say j minus minus j is 3. Now we come to this 0. So this 0 multiply 2 to the power j was 3. So this will be 0. And this 0 will be added with this previous answer. So answer is 16. Again, we are decrementing this j and j becomes 2. Again, we are going to the next element and we say this ai. So this ai multiply with the power of 2. power of 2 means this j, and j was actually 2. So we say 2 to the 4, 4 1 are 4, and we are adding this with the previous answer. So previous answer was 16. So that means we have got 20 inside our answer. Correct? And so on we will keep on doing, and at last we will get the total sum, this, that means 23 in decimal representation inside this final answer. Now the same process we can do in the reverse direction also. So in this case we will start from I equal to 4 to I equal to 0, and in this case we will be taking this power from 0, 1 and so on. So here j will start from 0, and we will be incrementing j in each iteration so that we can move from 0, 1 and so on. So if we see what is the time complexity in this array case, so time complexity will be on, because we are traversing the array in on time, that is we are linearly traversing. And what will be the space complexity? It will be O1, because answer will take constant space and there is no extra space we have taken. So space complexity will be constant space. Now as you know, whenever this power function will be called, then it will take some time for its calling. That means it will also add some thing to the you can say time complexity. So the question is, can we do something better? That is, instead of this power, can we do the same thing, that is multiplying with 2 in some another way? So let's see how we can do that. So we know that this 1 is in binary. In decimal also it will be 1. If we have written 1 0, then in decimal it will be 2. In binary, if it is 1 0 0, then decimal will be 4. And in binary 1 0 1 will be 1 0 0 plus 1, that is 4 in decimal, plus 1 in decimal, that is 5. What I want to convey is, for example, we know the answer of this part, that is we know that what is the decimal representation of 1 0. So 1 0 means 2 in decimal. For example, we know this, that 1 0 means 2. Now when we come to this ai, that is 1, now we want to find what is the integer representation of 101. So 101 is actually 5. So the question is, with the help of this previous answer, that is the previous answer was 2, can we generate this 5? So yes, we can generate. How? So we can say the previous answer 2, let's multiply it with 2. So it is 4. And now just add this ai. So it will be 2 into 2, 4 plus 1, 5. So this is 5. Now question is, given this ai, can we generate the total answer of 1011 from this 5? Yes, we can generate. What we can do is, we just multiply this 5 with 2, that is 5 multiply 2, and then here it is 1, so we just add 1. 5 to the 10 plus 1, that is 11. So if we see 1011, this only is 11. Let's say if it is here 0, then 5 into 2 plus 0, that will be 10. So 1010 is actually 10. So this formula is working. The formula is just take the previous answer, multiply it with 2, and then add the current ai. So why it is working? So we have seen that whenever we are adding 1 0 to the right side, so actually it is just multiplying with 2. And if we are adding 1, then we just add 1. And if the new digit is 0, we are just adding 0. So that's why this formula is working. So we can just change this to this code, and we can, instead of multiplying and using the power function, we can just use the left shift operator. So left shift operator is actually the equivalent to something multiply with 2. So here for I equal to 0, this 1 will be present, and what we are doing is, we saying answer is initially 0, 0 into 2, that means 0, and 0 plus 1, that means 1. Now we come to this 0, and we say the previous answer was 1, 1 multiply with 2 plus the current ai, and the current ai is 0, that means 2 1 are 2 plus 0, 2. So this total is 2. Now again we say a of I that means a of 2, that is 1, and the previous answer is 2. So this line will say the previous answer multiply with 2, because left should be multiply with 2, plus the current AI was 1. So 2 to the 4, that means we are saying 1 0 0. If it were to be 0, then it will be 1 0 0, that means 4. So this 2 to the 4 is giving me that thing, and plus because this AI is 1, so I am adding. If it were to be 0, then 4 plus 0 would be 0 only. So this is how this is working. Next, it will say that this whole answer multiply with 2 plus AI. So this whole answer is actually 11. 11 multiplied to 22 plus AI, that is 1. That means 22 plus 1, 23. So this is how I am getting 23, the integer representation of this binary form. So instead of this power, I can use just left shift operator. So this left shift operator is less time consuming in comparison to the multiplication operator. Now let's see how we will do the same thing in case of linked list. So this is the linked list and this is the head of the linked list. So the first solution we can do is, let's say we are given this function and the head is passed, that is this head. Now we will iterate from the starting of this linked list to the ending of the linked list, that is till head is not equal to null. And in each iteration we will do the same thing that we did in the array case. So we will just left shift the answer and then we will add the current value, that is head arrow value. That means these are the head arrow value. Clear? And in each iteration we have to move the head to the next, that is head equal to head arrow next, as we are doing I plus plus in case of array. So here only one traversal is needed and we can find our final answer. So here we can say return answer. Now we have the another solution also, and this solution will be needing two traversal. And what is the solution? We first count the total nodes. So in this case we have c equal to 4. Total nodes are 4, 1 0 1 1. Now as we know that we were multiplying each digit by its weight. So here we were multiplying 1 with 2 to the power 3. Here we were multiplying with 2 to the power 2, 2 to the power 1 and 2 to the power 0. Now this C is actually the total number of nodes. So this C will be helping me to generate this 3210. So I will be saying that till head is not equal to null, I am saying this head arrow value multiply with 2 to the power this C. And we have seen that C equal to C minus 1, that is C start from 3. So here we are doing that head arrow value multiply power of 2 comma C. So this will be 2 to the power 3. Again we are multiplying this 0 with 2 to the power 2. Head arrow value multiply 2 to the power C. And we are storing this answer inside this answer. We are adding the previous answer. And we are just moving the head to the next. So this will need total 2 traversal. So this was our question. Now let's see the code. So I have written the code that we have discussed. So here answer is 0, and while head is not equal to null, we are saying answer equal to answer left shift 1 plus head arrow value. And we are moving head is in each iteration. And we are moving head in each iteration. And after that, we are returning the final answer, that is the final integer value. So let's run it and we see that there are no error. And let's submit the code. So the answer is accepted. Now one thing to note is that you have to keep this bracket as such, that is you cannot remove these brackets, otherwise your answer will be wrong. For example, if I submit this, then you will get the wrong answer. So it is due to the precedent and associativity of the operator. Plus has higher precedence than this left shift operator. So you have to just keep these brackets as such, otherwise your answer will come as wrong. So I hope you have understood the solution. If you have any comment or suggestion, please put down into the comment box. Let's meet into the next video. Goodbye.